A galaxy is shining through 13.4 billion years of darkness. It should be a newborn. It looks more like a teenager. And right now, that one impossible detail is shaking the story of the early universe. If real space mysteries like this pull you in, subscribe now. The deeper we go, the stranger this gets. And the next clue makes the whole thing even harder to explain. For a long time, scientists had a simple picture of the early universe. The first galaxies were supposed to be small, dim, messy, and very young because there had not been much time for stars to live, die, and build anything complex. That idea made sense because the universe itself was young, still coming out of its earliest dark ages, when space had cooled enough for the first stars to switch on. If you looked back far enough, most experts expected to see cosmic babies, not giant systems already acting older than their age. That is why the James Webb Space Telescope matters so much. It was built to look farther back than Hubble could, into a time often called cosmic dawn, when the first real galaxies began to rise out of the darkness. Webb does this by seeing infrared light, which is light stretched by the expansion of space so much that ancient starlight arrives redder and weaker than it first began. In simple terms, Webb is built to catch the oldest glow still moving across the universe. Before Webb launched, computer models gave scientists a rough map of what they thought they would find. Not every detail was certain, but the overall story seemed stable. Early galaxies would be tiny, early chemistry would be simple, and really massive systems would need more time to grow. That is because heavy elements, things like oxygen and carbon, are not made in the Big Bang in large amounts. They are made inside stars, then thrown out into space when those stars die. So if a galaxy is very young, it should mostly contain the simplest stuff. Hydrogen and helium should dominate because those were the main gases born near the start of everything. A little later, the first stars would light up, burn fast, explode, and slowly enrich space with heavier elements over many generations. That slow build was not just a guess people liked, it was part of the basic timeline many astronomers used to understand how the universe grew up. Then Webb went to work, and the clean story started to crack. Survey teams began staring into tiny, dark patches of sky and finding more bright early galaxies than many models expected. At first, some scientists thought there had to be mistakes in the distances, because when something seems too far, too bright, and too early, the safest first thought is usually caution. Maybe the object only looked ancient, but was really closer and easier to explain. One of the biggest searches was called JADES, short for the JWST Advanced Deep Extragalactic Survey. This program used Webb's cameras and spectrographs, tools that do not just take pictures, but also split light apart so astronomers can tell what an object is and how far away it sits. In 2023, the team noticed a strange source hiding in the data, bright enough to make people uneasy because bright and very early were not supposed to go together so easily. It even sat close to another galaxy, which made the signal harder to trust at first. That caution mattered because distance in deep space is tricky. Astronomers often use something called redshift, which is just a way of measuring how much the universe has stretched the light on its way to us. The more stretched the light is, the farther away the object usually is, and the farther back in time we are seeing it. So before anyone made a huge claim, they needed stronger evidence than a strange-looking dot in one picture. When the follow-up data came in, the room changed. Webb's near-infrared spectrograph studied the light for nearly 10 hours, and the answer was sharp enough to end most of the doubt. The object, named JADES-GS-Z14-0, had a redshift of about 14.32, which means we are seeing it less than 300 million years after the Big Bang. More exactly, the light we see left when the universe was about 290 million years old, only around 2% of its present age. Did you expect the first great galaxies to be tiny and faint, not bright enough to break the record this badly? Tell me in the comments what you would have guessed before Webb started sending back these results. And if you like space stories where the real science is stranger than the hype, subscribe. Just stop on that number for a second. The universe today is about 13.8 billion years old, so this galaxy is showing itself from a time so early that most cosmic history had not happened yet. Dinosaurs, Earth, the Sun, the Milky Way as we know it, all of that was unimaginably far in the future when this light began traveling. Yet JADES-GS-Z14-0 was not merely there, it was already shining hard enough for Webb to catch it across 13.4 billion years. That alone would have been enough to make headlines. But the real shock was not only the distance, it was the personality of the galaxy, if you want to call it that. because this object did not behave like the frail first systems many people expected to find. It looked too bright, too large, and too active for something born so close to the beginning. The team found that JADES-GS-Z14-0 spans about 1,600 light-years across. That may sound small next to the Milky Way, which is roughly 100,000 light-years wide, but for such an early moment, 1,600 light-years is still a serious structure. This was not just one lonely star or a weak spark barely holding itself together. It looked like a real galaxy, with enough stars to make astronomers ask a harder question. How did it build itself so fast? And there was another surprise tied to that brightness. Webb's images suggested the light was mostly coming from young stars, not mainly from the hot chaos around a feeding supermassive black hole. That matters because if the glow is mostly starlight, then the galaxy itself must already contain an enormous amount of stellar mass for its age. In plain English, nature had somehow packed a lot of galaxy into very little time. Some researchers estimated that it held several hundreds of millions of times the mass of our Sun. That does not mean it was the biggest galaxy ever seen, of course. It means that in a universe still younger than 300 million years, this object had already done enough building to embarrass many early growth models. It was like showing up at a nursery and finding one child already acting like a middle school student. The surprise did not stop with size and brightness. Webb also saw hints that the galaxy was not as blue as a purely fresh, simple young system might be. Part of its light seemed reddened by dust, which is important because dust also has to be made. Dust does not magically appear in large amounts at the start. It forms from material made by stars and blown out into space. Then came one of the most unsettling clues of all. Using Webb's mid-infrared instrument called MIRI, scientists saw brightness at longer wavelengths that did not fit a simple newborn picture. That extra brightness suggested strong emission lines from hydrogen and oxygen, which means the gas in the galaxy was already being lit and shaped by energetic processes. And oxygen, that was the detail that made the entire story turn from surprising into deeply uncomfortable. Oxygen is a heavy element. Heavy elements are made inside stars. So if you detect oxygen in a galaxy this early, you are not looking at a place where one generation of stars has just barely started. You are looking at a place where massive stars may already have formed, lived fast, died, and enriched their surroundings enough to leave a clear fingerprint. That means time is no longer the only mystery. Speed becomes the mystery. How do you get multiple generations of stars, enough chemical change, enough dust, enough light, and enough structure in less than 300 million years? That is why people were not simply excited by JADES-GS-Z14-0. They were thrown off balance by what it seemed to be saying about the whole early universe. If you had to guess, what would shock you more here? The distance, the brightness, or the oxygen? Drop your answer below because each one changes the story in a different way. And hit like if the oldest light in the universe just started feeling a lot less simple. In March 2025, the next major twist arrived. Two independent teams used the Atacama Large Millimeter/Submillimeter Array, better known as ALMA, to detect oxygen in JADES-GS-Z14-0 more clearly. ALMA is not the James Webb Telescope, but together Webb and ALMA make a powerful pair, because Webb can find these ancient galaxies, and ALMA can test what their gas is really doing. What they found pushed the case from suggestive to serious. The result was not just that oxygen existed there. The result was that the galaxy looked much more chemically mature than many astronomers expected for that time in cosmic history. One team said the system seemed to have about 10 times more heavy elements than expected. That is the kind of number that does not just tweak a model at the edges. It forces people to rethink how fast galaxy growth can happen. One scientist compared it to finding an adolescent where you would only expect babies. That image stuck because it captures the feeling so well. Nobody is saying the laws of physics broke, but the pace of events seems faster than the old versions of the story allowed. The early universe was supposed to be learning how to crawl, and instead Webb may have caught parts of it already running. ALMA also helped nail down the distance with remarkable precision. The uncertainty became tiny, around 0.005%, which researchers compared to being accurate within 5 centimeters over a distance of 1 kilometer. That kind of precision matters because extraordinary claims get weaker if the distance is shaky. Here, the distance did not fall apart under closer study. It became even harder to dismiss. So the central mystery grew sharper. Scientists once thought the first few 100 million years would mostly show primitive building blocks. Instead, this galaxy already shows signs of real chemical processing, strong starlight, and a scale that feels too advanced for its age. The gap between what was expected and what was found is exactly what makes this discovery feel so important. It hints that our timeline for the universe's early growth may be too slow. There is a deeper reason that gap matters. If galaxies could build heavy elements this quickly, then stars were forming, burning, exploding, and recycling matter earlier and faster than many models predicted. That changes more than one object in a catalog. It changes the speed of enrichment, the pace of structure, and even the likely conditions for later galaxies that would come after these first bright systems. It also raises a dark matter question. Some astronomers noted that JADES-GS-Z14-0 seems to push against what people thought might be the maximum mass of a dark matter halo at that time. A dark matter halo is the invisible gravitational structure that helps gather normal matter and gives galaxies a place to form. If the galaxy really is that massive that early, then either it was extraordinarily lucky, or our ideas about early structure growth need serious adjusting. There is also a numbers problem hidden inside the brightness. One report noted that this galaxy appeared roughly 5 times more luminous than the previous most distant record holder. That is not a tiny step forward. That is a leap, and leaps are what make scientists nervous, because a leap may mean you found a rare outlier, or it may mean your broader expectations were set too low. Now think about what this means emotionally inside the field. Astronomers are not upset because discovery is bad. They are excited because the universe is doing what it does best, refusing to stay inside the clean boxes we build for it. But excitement comes with pressure, because every new odd object forces a choice. Fix the model, widen the model, or accept that something bigger may be missing. Did you ever expect one ancient galaxy to start a fight over how fast the whole universe grows up? Tell me below whether you think this is a rare cosmic freak or the first clue of a much bigger pattern. And if you want the next surprise as soon as it drops, subscribe and stay close. At first, it was easier to treat JADES-GS-Z14-0 as one weird exception. Science often does that, and for good reason. A single oddball can fool you, especially when you are looking at the faintest, farthest objects ever studied. But Webb kept seeing other hints that the early universe may have been busier, brighter, and more mature than people had planned for. Over the last 2 years, a wider pattern has started to take shape. Webb has found strange compact objects called little red dots, tiny red sources that may hide rapidly growing black holes in the young universe. These objects matter because they suggest early growth was not only about stars. It may also have involved black holes getting very large very fast in a cosmos that was supposed to still be in its opening act. One striking case is called Abell 2744-QS01. Webb saw it as it was about 700 million years after the Big Bang, and follow-up work showed signs of a black hole with a mass around 50 million suns. That alone is impressive, but the more unsettling result was that the black hole seemed to make up at least 2/3 of the object's total mass. Nearby galaxies do not usually work like that at all. In most galaxies around us today, the central black hole is important, but it is still only a tiny fraction of the whole system. In QS01, the balance looked wildly different. The gas around it showed a clean orbital pattern, a sign that most of the mass was concentrated in the black hole itself. And the surrounding material appeared extremely pristine, meaning it had very little of the heavier elements you would expect from a fully built stellar population. That points to a disturbing possibility. Some early supermassive black holes may not have grown slowly from small stellar remnants at all. They may have been born large, either from direct collapse of huge gas clouds or from other heavy seed processes scientists have debated for years. If that is true, then the early universe may have had more shortcuts than we realized. So now place JADES-GS-Z14-0 back into that bigger picture. On one side, Webb sees galaxies that look too bright and too chemically mature too early. On the other, it sees signs that giant black holes may also arrive early, perhaps even before some galaxies are fully assembled. Different clues, different objects, same feeling. The first chapter of cosmic history may have moved much faster than the textbook version. This is where the story shifts from what happened to what is happening now. Right now, astronomers are not just celebrating a record distance.
They are testing whether Webb has exposed a real weakness in our models of early star formation, black hole growth, and galaxy assembly. Every new observing run is now part of a larger question. Was the infant universe actually a lot less infant-like than we thought? That question matters because science does not move by comfort. It moves by tension between expectation and reality. If reality keeps winning in the same direction, meaning brighter galaxies, faster chemistry, heavier early systems, and bigger black holes, then theorists have to rebuild the timeline. Not from scratch maybe, but enough to admit that the old pace of cosmic development may be wrong. What do you think is harder to accept? Galaxies growing too fast, or black holes showing up already huge? Comment your answer, because that split is becoming one of the biggest arguments in modern astronomy. And tap like if you want more stories where one discovery changes a much bigger picture. There is another reason JADES-GS-Z14-0 feels so powerful. It is not just far away. It is far enough that we are looking into an era where almost every conclusion still feels fragile, because the sample size is small and the observations are incredibly hard. So when one object comes in this strong, with this much light and this much chemistry, it pulls on the entire edge of what we think we know. That is why researchers are careful with their words, even when they sound stunned. They are not saying the Big Bang is wrong, and they are not saying physics has collapsed. They are saying the early timeline inside the standard picture may need updating, especially the parts about how quickly matter can clump, how quickly stars can form, and how quickly galaxies can enrich themselves with heavier elements. Those are huge changes, even if the broader framework stays standing. Webb's power is that it can force that update faster than older telescopes could.
Hubble pushed deep into the past, but Webb is seeing farther with more detail in the infrared, where the oldest light now lives. It does not merely show that early galaxies existed, it shows texture, structure, color, and chemistry, the pieces that tell us whether those galaxies were weak sparks or already serious systems. And the more detail we get, the less comfortable some old assumptions look. If early galaxies really formed stars in bursts stronger than expected, then models may be underestimating how efficiently gas turned into stars. If heavy elements appear too soon, then maybe the first massive stars formed earlier, died faster, or lived in conditions that accelerated chemical change. Each fix sounds technical, but together they redraw the first few 100 million years of history. This also changes the hunt for what comes next. Astronomers are now searching not just for more distant galaxies, but for more distant galaxies that already look oddly mature. They want to know whether JADES-GS-Z14-0 is rare, or whether Webb has only opened the door to a crowd of similar objects waiting in deeper data. If there are many more like it, the pressure on current models rises sharply. There is a thrilling danger in that possibility. If we keep finding brighter, earlier, more evolved systems, then every new record holder will do more than push a number. It will tighten the argument that nature started building complex cosmic structures almost as soon as it was physically able to do so. That would mean the universe wasted very little time turning simple gas into organized, star-filled systems. Another present-day clue comes from objects that may show black holes forming in ways never confirmed before. In 2025, NASA highlighted a strange system nicknamed the Infinity Galaxy, where researchers argued that a supermassive black hole may have formed in the middle of colliding gas, not inside either main galaxy core. Then, in 2026, Webb work suggested at least one early black hole may have formed before its host galaxy was fully built. Those results are still being tested, but the pattern keeps leaning the same way. So, while JADES-GS-Z14-0 is one galaxy, it does not feel lonely anymore. It feels like part of a message, one that Webb is spelling out letter by letter. The message is that the early universe may have had a wild efficiency we did not appreciate, an ability to make stars, dust, oxygen, and maybe even giant black holes at a startling pace. That does not make the cosmos magical. it makes it more impressive and harder to predict. If Webb keeps finding ancient systems that already look oddly grown up, where do you think the next shock will come from? Leave your guess below, because the next answer might involve even earlier galaxies, even heavier chemistry, or even stranger black holes. And if that kind of unfolding mystery is your thing, subscribe before the next clue lands. Now zoom out for a moment. Why should anyone outside astronomy care whether one distant galaxy had oxygen too early or shone too brightly for its age? Because this is not only a story about one record in one telescope image. It is a story about how quickly the universe learned to make complexity, and complexity is the path that eventually leads to planets, air, oceans, and people. The oxygen in your lungs was forged inside stars. The carbon in your body, the calcium in your bones, the iron in your blood, all of it comes from cosmic furnaces that lived and died long before Earth existed. So when Webb shows us heavy elements appearing shockingly early, it is showing us that the universe may have started building the ingredients of later worlds sooner than we believed. It is a very distant story that still ends inside you. There is also a human lesson in this. We build models because we need them. They help us predict, compare, and make sense of chaos. But nature does not owe us simple timing, and one of the healthiest things in science is when a machine like Webb arrives and humbles a whole field by showing that reality is larger, faster, or stranger than our neat expectations. That is why these discoveries feel so alive right now. They are not closed museum facts. They are part of an argument still unfolding in real time, with new data still coming, new papers still being checked, and new ideas still fighting for survival. We are watching the map of the early universe change while the ink is still wet. And that makes this one of the best moments to be paying attention. 100 years ago, we were still debating whether other galaxies even existed beyond the Milky Way. Now we are arguing about the chemistry and maturity of galaxies seen less than 300 million years after the beginning of cosmic time. That jump in understanding is almost unbelievable, and yet it is happening within living memory, in public, image by image. JADES-GS-Z14-0 may not remain the distance record forever. In fact, it almost certainly will not. Webb is likely to find even earlier galaxies over the coming years, and some may be stranger still. But even if this object loses the title, it may keep its importance because it forced one of the biggest questions in modern astronomy into the open. How did the universe grow up this fast? Maybe the answer will turn out to be a mix of things. Maybe star formation was more efficient. Maybe dark matter structures formed useful pockets faster. Maybe feedback from early stars worked differently. Or maybe black holes and galaxies helped each other grow in ways we have underestimated. Science often ends that way, not with one magic bullet, but with several missing pieces finally clicking into place. Right now, we still do not have all those pieces. What we do have is a telescope that keeps pushing into the unknown. Webb was built to see the first light, and instead, it may be forcing us to rewrite the first schedule. That is a very different kind of success. It is not just confirming what we hoped, it is exposing what we did not understand, which is the kind of discovery that usually matters longest. Do you think the universe was always destined to surprise us like this? Or do you think Webb has only found a few rare exceptions? Tell me in the comments, because that may decide whether this is a weird chapter or a whole new opening book. And if you want more deep space mysteries told simply and clearly, stay subscribed. The deepest wonder here is not that one telescope found one faraway object. It is that light older than Earth, older than the Sun, older than the Milky Way's familiar shape, can still arrive here and change our minds. That means the universe is not silent. It is still sending messages, and we are only now building the tools sharp enough to read them properly. So when people say James Webb just revealed something no one was prepared to see, this is what they really mean. Not that astronomers never expected surprises, but that the surprise came in a form too mature, too bright, too chemical, and too early to fit comfortably inside the old picture. A galaxy less than 300 million years after the Big Bang should have looked like a beginning. Instead, JADES-GS-Z14-0 looks like the beginning already has a history, and that is the part that stays with you. Somewhere out in the dark, long before our world existed, stars were already burning, exploding, and changing the makeup of space faster than we imagined. A galaxy was already growing teeth. The early universe was not waiting around, and the farther Webb looks, the more that first wild rush of creation starts to feel real. If this story grabbed you, subscribe now and turn on notifications so you do not miss the next impossible signal Webb sends home. Then comment with your answer to this question. Do you think JADES-GS-Z14-0 is a rare cosmic outlier, or proof that the early universe grew up fast everywhere? And share this with someone who loves space, because this is one of those discoveries that sounds unreal until you look at the numbers. The first galaxies may not have been babies for long. The universe still has more secrets than answers. I am glad you were here to explore one of them with me. Thanks for watching.